Alrighty, hello everyone, and welcome to our experimental design notes for pages 6 and 7. So, in this video, we're going to talk a lot about the different tools that we can use to analyze data. We're going to talk about hypotheses and theories and laws and what all those are and what they mean, and a few other things. So, let's go ahead and get started with what tools do we use to analyze data. A lot of times we use graphs, tables, charts, pictures, and words. We use quantitative and qualitative information in order to talk about our data, in order to analyze our data. I don't know about you guys, but graphs just speak to me. I can look at a graph and look and determine what the relationship is. So that's how I like to analyze my data. But maybe you like to use charts or tables, or maybe you can create some type of picture, or maybe reading words helps you analyze the data. The reason why we analyze data is so that we can draw conclusions about the information that we collected. We can't draw conclusions if we don't look at the data, sit down, say, yes, there's a relationship, no, there's not. We need to analyze that data to communicate what we found. So let's get into scientific theory. So scientific theories are broad explanations for natural phenomenon. These include things like evolution, plate tectonics, gravity. Those are all broad explanations of natural things that occur. Theories have been tested many, many times by lots of different scientists. These are normally inferred explanations that are strongly supported by lots of evidence. We collected all this data over and over and over. Different scientists over hundreds of years collected data, and we were able to say, yes, this is still true. It's strongly supported by the evidence. Boom, scientific theory. Now, scientific theories can also be used to make predictions about other things and what might happen next. A scientific theory explains why something is happening. Scientific law is what is happening. So, scientific theory, why? Scientific law, what? Scientific law describes a natural phenomenon. So, I have this table here to show you kind of the difference between scientific laws and scientific theories. You can look through this and see all the different things that they have, kind of the same, kind of different. One of the main things that I'd like to point out is that typically scientific laws will say Newton's law, the law of inertia, Boyle's law, all these different things. Scientific theories will often say theory in them. So, theory of relativity, the Big Bang theory, theory of evolution. Another thing that I would like to point out too is that scientific laws are proven, scientific theories are proven, but still testable. Now let's talk about scientific hypotheses. So these are proposed explanations for a narrower set of natural phenomenon. This is based on prior experience, background knowledge, and preliminary observations. It's normally a statement that can be tested. It's a prediction about the outcome of an investigation. It helps to guide an investigation or what we're going to be measuring. And oftentimes, hypotheses are formatted in if then statements. So, if I drink a lot of coffee, then I'm going to feel more awake. So, here's a table that's going to compare hypotheses, theories, and laws. So, don't feel like you need to write all this down, but just sit here and try to think about how these three things are related. Now, when you're done thinking about that, you pause the video, you thought about it. I'm going to show you this. So, hypotheses can become theories, hypotheses can also become laws, but it all starts with an observation. That observation then draws us to think about some possible hypotheses. Those hypotheses can become theories. Those theories can become laws if they're proven to be true. Okay, let's talk about evidence versus explanation. So this is a justification of what we're looking at. Evidence is the data. It's what happened in the experiment. It's what we collected. It's what we found. Explanation describes why something happened. Why did we see that data? Why did those conclusions come true? A good scientific explanation uses evidence to justify a claim. You need to be able to say what you believe that experiment showed, and you need to be using the evidence that you found, the data that you collected, to explain why the data you found happened. Both evidence and explanation support the claim that we made about whatever scientific investigation we're looking at. And those are used to respond to the testable idea. That ends our note video for pages 6 and 7. So I will see you when I see you.